In this laboratory lesson, we will develop a simple C++ node that listens for messages coming from the Arduino through the serial port and republish each new message that is received in a ROS2 topic. So let's go back to Visual Studio Code, and in the BumperBot firmware package in the source folder, let's create a new script called simple serial receiver.cpp, and as in this script we are going to develop a simple C++ node that publish messages inside our ROS2 topic, we can copy the content of the simple publisher node that we have already created within the BumperBot cpp example, and so within the source folder. So let's take the simple publisher, let's copy it, and let's paste it within the simple serial receiver node. Here, let's just change the name of the class. So let's use Ctrl F, and let's change this one to be simple serial receiver. So let's change all the occurrences of this node. Also, let's change the name of the node here. That is the simple serial receiver, like this. And also we want to change the name of the topic in which we want to publish the new messages that we receive from the Arduino through the serial port. And let's call it, so here, the serial receiver topic. So here in this topic, we're going to publish any new message that we receive from the Arduino board. In this class, we are not going to need the counter variable. So actually we can remove it, and also we can remove it from here, since we are going to publish the messages that we receive from the Arduino. Furthermore, let's also change the frequency of the timer, and so this one, let's instead set it to 0.01 seconds, so that the ROS2 timer executes the timer callback function every 0.01 seconds, so with a frequency of 100 Hz. At this point, we can implement the actual logic to send any new message that we receive from the Arduino to the serial receiver topic, so to this topic here. In order to do so, as we did in the previous lesson, let's include from the lib serial library the serial port, so let's include this class, and let's create a new object of this class. So here among the private variable from the lib serial, let's create a new object of the serial port, and this is called Arduino. And now within the constructor of this class, let's open the serial port. So let's start the communication with the Arduino. We can do it here. So let's use the function open in order to open the communication with the Arduino. And as we did in the previous lesson, this function requires an input, that is the port to which the Arduino board is connected with the USB cable. Instead of hardcoding this value inside this script, as it can happen that the Arduino board is connected to a different port, we can use the ROS2 parameter to configure this value. So we can actually copy these lines from the simple serial transmitter, and here we can copy these two lines here that are declaring the parameter port and also that are reading the parameter port. And let's paste it here. So before we open the connection with the Arduino, also let's declare here the string port as a member also of the simple serial receiver class. So let's declare it here, and now we have also the variable port, and now we can use this variable in order to start the communication with the Arduino. So let's pass this string, so the port. Also let's set the baud rate with the Arduino set baud rate, and also in this case I'm going to use from the lib serial, and from the baud rate I'm going to use the baud 115200, so this one here. Since in the constructor of the simple serial receiver class we have opened like this the communication with the Arduino, so with the serial port, we also have to remember to close it, so when we have finished with it. And so we can define the destructor of the simple serial receiver class. So let's define it like this. And whenever we destroy this class, we simply want to close the communication with the Arduino. So let's call the close function like this. Now, at this point, in the timer callback function, so this function here we can first check that actually everything is working, that actually the ROS2 node is up and running. So with the RCL CPP, okay, so let's check that RCL CPP, so the interface with ROS is on, so it's available, and also let's check that the serial port, so the Arduino, is connected. So actually let's check that there is any data available. And if this is the case, so if the ROS communication is on and there are new data available coming from the Arduino, let's simply read the new data that the Arduino is sending. So let's use the Arduino, the readLine function, and let's read the message that the Arduino sent through the serial port within the message that we want to publish within the serial receiver topic. So this variable is already created, so actually we can declare it before its usage, and now we can save it. So we can save the line that we have read from the Arduino within the data of this message, and then simply we can publish this message. So actually we don't need anymore this line here, we simply need then to publish this message. With this, the simple serial receiver class is completed, and also our C++ node is ready to read messages from the serial port where the Arduino is connected and to republish them inside the ROS2 topic called serial receiver, this one. As a last step for this lesson, let's simply install this node within the cmakelist.txt file. Actually, we can copy the same instruction that we have used to install the simple serial transmitter node, and let's declare this time the executable is the simple serial receiver, and also the source code is the simple serial receiver.cpp. Let's also change the name of the executable in all the places in which we have used it, and also let's remember to install it, so within the install instruction, and so now we have also installed it. Now, as we have not introduced any new dependency from this node, we don't need to update the package.xml, and we simply can build the workspace in order to check that we have not made any mistake. So let's go to the workspace and let's build it with colcon build. The workspace compiled successfully, so our new node is installed correctly, and in the next laboratory lesson we will start this node in order to see how it works and how to communicate, so how it receives messages from the Arduino.